guys, welcome to the video Introduction to Scilab. Today we are going to learn about Scilab, and this will be an introduction section. Then after we will move on to in-depth study of how we can use the Scilab to solve the numerical problem. So let's start. Let us start with what a Scilab is. Scilab is an open software which is named as Scientific Laboratory. It is a high-level programming language designed for the numerical computation and has extensive library tools for performing the numerical calculation. There are a number of softwares that are available, but I have chosen Scilab to introduce because Scilab is an open software for data analysis and processing of the numerical examples. Scilab is an open software that is a replacement of MATLAB and is nowadays used by the researchers for data analysis and for creating the programs for solving the numerical problem. If we talk about MATLAB, so MATLAB is a fourth generation high-level language that provides interactive environment for numerical computational visualization and was invented by Moeller in 1970s. Now MATLAB is a purchase software, means if I have to use MATLAB then I have to go for the MathsWork website and I need to purchase it. But Scilab is a substitute in which we are just going to download it in our system and we can use it free of cost. It means it is an open software. So from where you will get Scilab? Obviously Scilab is available for freely downloading and it is available on scilab.in, or you can visit scilab.org for downloading the version, and the version that I have taken for the discussion here is 2023, the latest version which is available right now. And another substitute where you can work for the Scilab if you don't have the software being downloaded is octaveonline.net. So it is a place on the internet, or I can say it is a website on the internet from where you can practice the things directly without purchasing or downloading a software. Now this is the window that is being shown when I am going to scilab.in. So it is scilab.org, that from where I have seen the versions which are available, and according to the choice of the windows you can download the latest version. Now if we talk about the windows in Scilab, so the workspace, that is when you are opening after launching the software, you will be able to see the different windows. So let me show you first. This is the type of file browser window that will come up. Here the in between one, this one is the console. It's saying starting up execution, means here it is a console where you can work with. This is a window where you can see the path is being shown, that where my programs will be saved. I can even create my own folder there and the future work will be saved there. This is a variable browser. When I will work on the variables, then variables will be shown here. This is command history. So command history is a place where whatever commands I have used till now will be shown as a history, and I can even click it to get it again back in the console. Other than that, we have editor window and figure window that we will learn in the course of time when we are going to do some programming and create the figures. There is one more good option in Scilab is changing preferences. If I want to showcase you, and I have launched the software, so I can see that the letters and the fonts are very dim, the colors are not so bright. So I can go to edit, and in edit you can have preferences. In edit tab you can go to preferences. I will show you also, and from there I can change the font, the size. I can make the font even bold, italic or monospace of the console as well as for the editor window, right? So this is that how you can customize the presentation. Now let us start. First, before going to this, let us have the software. So this is what I have started with, and I am getting a window. You can see this is just now I have launched. So it's showing me the console. This is where I can type the command. These are the windows that we have just discussed, and you can see now it is open. So on 27th I have done with some of the work, so it's showing me as a history, right? Yesterday might be I have just tried to exit because it was not executing well, so it is the command. And today I have started for this session just now, and it is just blank, right? So let us start with the first thing, that how I can see the things will work. So I have shown you edit and preferences. So here is the tab from where you can set your preferences. So when you will go to edit preferences, a window will pop up and this is the window that you can see. Here you can customize the way you want to give. I have given the 24 and make it bold. You can change it as per your choice, right? And here is a tab, apply. So as soon as you will click OK, after applying, the changes will come into the picture, right? So this is how we can work with the software. Now let us start with the basic requirement that many times we are learning by ourselves. So what we need is, we need help. Obviously we are here to help you, but if we are exploring something by our own, then we need a help, and the help keyword is there in the software to take help for anything. For example, let me write on help. Now what is the syntax of taking help in Scilab is help followed by a bracket, then I have to put curly braces, and let me write on the first command I am going to share with you, CLC, clear screen. So CLC is a command. Let's see how it is going to help me. It has opened a pop-up window, and you can see it's showing me the syntax, the things that are coming along with CLC, right? But it is just to showcase. But when we are implementing, CLC is to clear the console, means the console where I am right now working will be cleared if I will press CLC. So let me write down CLC, press an enter, and it's saying, are you sure to want to clear? Yes, I said, and I have clicked the do not show the message again. Yes, so the console is clear, right? So this is one thing that we have taken. We have taken help in Scilab, and we have learned the command CLC. Let's move on. Now what the next thing is, as we have typed CLC, what we have done, we have pressed the enter key. So this is that whenever any of the command I am using to get the required output, how the command is working, we need to press enter key. And one more good feature of Scilab is that I can use the arrow keys up, down, back and forth to use the already used commands. Now what it means is, let me show you. Here just now I have used help command, then I have used CLC. So now I am using arrow key and it's showing me CLC. So I am using up arrow key. I am using now down arrow key, and I can use the right and left key to move back and forth, right? There is one more shortcut of CLC. You can see this brush is there, and if I will show you what it works, so it's showing me clear console. So we have some shortcuts also that you can explore by your own regarding a number of functions are there being given to us as a feature, right? So this is how we have worked, and we have used the arrow keys, right? Let's start moving with the next one, that is how we can start working. So here we are going to learn two commands. One is printf and another is display. And what is the purpose of this command is, printf is a command to print whatever I am going to write down in the bracket followed in the quotes. So I am writing out welcome. I think it's enough. Let's see how it will appear. This is the output, right? And if I will use the arrow key to write it down again, but I'm using a display command, the ASP. Now see, it's coming again as welcome, but there is a change, and the change is, one is in the line spacing, another is the justification, and one more is the double quotes, right? So you can choose as per your choice, right? So this is the basic command how we can type in Scilab, right? So let's move on. Now another feature of Scilab is that we can use Scilab as a calculator. Right now we all have a calculator, and we know that mobiles are having a calculator, but this is how in programming we can do the calculation. So let's start with some basic calculation. Here I have written the addition sign and the caret sign, right? So let's see how we will work. Let us take any two number, let us say 2 plus 9, and I will write, press enter, it's giving me the answer. So you can see that by default the answer is coming as ans. So I can understand it as a variable holding the answer, right? And you can see here in the variable browser, answer is 11. Now let me talk about caret symbol. It's coming with shift 6. So 4 caret 2. What is 4 square? I know, 16. So 4 cap 2 will give me 16, right? And one more thing that you might have noticed is why it's 11 dot or 16 dot. Yes, you are right. If you know programming languages, these are being stored as a float number, means a decimal after the number. So this is how it is storing the result, right? Other arithmetic operations can also be handled directly without even writing out any variable or syntax. So let me say 17 minus 2. So it's giving me 15. Let us say 12 minus 18. The answer is minus 6. Right? It's correct. We have done with addition, subtraction, caret symbol. How to multiply? So we have asterisk symbol with shift 8. So asterisk is for multiplication. So if I write on 3 into 12, the product is 36. What next? Division, right? 12 divided by 2, 6. Right? So these are the basic mathematical operators that can be handled directly without any proper syntax to learn about. But what if I want to give a particular variable to hold a value? Right? So in that case, we need to define variable. Now what a variable is? Variable is a placeholder that can take some value and then I can use it at the later stage. Right? So let me take a simple example. First let me clear the screen using CLC. Now let us take, I want to find out area of a rectangle. Right? And what my teacher can provide me, they can provide me the length and the breadth of rectangle. So I can write on directly, but the proper way as we are doing in maths is, let me take length, E-N-G-T-H, length let us say 19 and B-R-E-A-D-H, breadth is 5. So I can say area is equal to breadth and it is giving me 95. Right? Now what these area, length and breadth are, you can see they are coming in variable browser. It means I have created these 3 variables, right? And area variable is taking the product of length and breadth. Now there are some specific rules that how we can create the variables. So here are the following rules, that whatever you are writing out either in caps or small, be sure to retain it. Means Scilab know that you have defined it as a uppercase or a lowercase letter and they should be different. For example, let us say I have defined L is equal to 3 and I am saying L plus 5. So it's saying undefined variable L because I have taken it as small one, right? So if I will use L plus 3, it is okay. It is 6 because it already has a value of 3. So it means capital and small are distinguishable by Scilab. So you have to take care. Other than this, we are saying that variables can store string delimited by either single or double quote. Right? Both are allowed as we are defining some variable as a string type. Right? Some other rules are that variables names can include underscore but can't use white space. Now what it means is I can name a variable as A underscore B as, let us say, a value 5. Okay, one more thing that till now you might have observed that when I am pressing enter, it's echoing the variable. No? But if I do not want to see, what I can do, I can suppress the output using a semicolon. So what actually we have discussed is that underscore is allowed as a variable name, and now I have suppressed the output using a semicolon. So see the difference, it's not echoed, means I have created, it's coming here in the name variable browser, but it's not echoed, right? So this is allowed. But if I say A, or let us say A space D is equal to 9, so it's giving me an error. So spaces are not allowed. Similarly, the next rule is I can write on a variable starting with an alphabet followed by a number. That is okay. There is no error. But if we start with a number with an alphabet, then this will be an error. It's a syntax error. So these are the rules that we need to follow to name a variable. Right? So we have discussed the second one, that variables can start with a letter or an underscore but not with a number. Similarly, one more thing that need to be taken out is that we have to avoid keywords and functions. Means if I want to create some variable, it should be unique as per the purpose, but do not write down those variables which are keywords or function in Scilab. So in the due course we will learn what are the keywords and functions. Right. So let us start writing out variable that stores a string that we have discussed and see that how we can define it. And you can see both are allowed. Here I have used single quotes, here in this example I have used double quotes. And if we talk about two variables, let us define is, we have written hello, and let me define ss as dear. So let me use here single quote, right? And I have obtained two variables, both are string variables. Now with string variables, just a simple manipulation that I can show you is if I will add the two. So if I add the two will be added and become a single string. Now is it looking fine? I don't think so. They are totally mashed or there is no space. So what I can do is I can put empty, you can say a space as a string in between, and I will get the desired result. Right? So this is how I can simple find out. This is a way how we can concatenate the two strings together. Right? So it's known as concatenation. Now again we are for the basics of mathematical operations. Now what mathematical operations are being supported? I think mostly all, and along with the addition subtraction there are divisions in left and right direction, exponent is there, and then we know that we have mathematics BODMAS rule, so Scilab also follows the BODMAS rule. Right? So let us start looking at that what are the two divisions, the left and the right division. So let us try to differentiate 20 by 4. It's a normal division, right? 20 by 4 is 5. But if I will use 20 by 4 and accidentally I have used this one, so what's the answer? Right, the answer is 0.2. 4 divided by 20. So the work will be in opposite direction. Right, so these are the two division operators in left and right both direction. What else we have learned about power? Now there are some keywords also that we can use, such as exponent. You know, e raised to something. So here we are calling it as exponent. So we have exp to write down exponent of a function. Similarly, we know about the logarithmic of a function. So it is log of 2. I think you might remember 0.693. Right? So this is how we can work with the operators. Right? So here we have taken some example, and similarly coming in the slides. Okay, we have done with the log. Right? And here you can see some more inbuilt functions are being defined, as absolute value could be there, trigonometric functions are there, inverse trigonometric functions are also there. So in the due course, in the next lecture, we are going to learn more about these mathematical operators. So we'll start from here. Thank you, and be sure to install software, try practicing, and I will tell you one more feature, that how you can dock and undock the windows in the next lecture. Thank you. Bye-bye.